Hello listeners and viewers, welcome to Kaduna State Ministry of Education Radio and TV e-learning program designed for our SS3 and other students staying at home due to the coronavirus pandemic. The present administration under the able leadership of His Excellency, Malam Nasir Ahmed El-Rufai, is positioned as always to ensure that under his leadership, our students are not left behind in all areas of human endeavors, especially education. Kaduna State is the center of learning. Therefore, we want to ensure that our students excel in their forthcoming examinations and beyond. Students and other learners at home are given this opportunity in order to continue learning, as education is a continuous process. Different subjects will be taught in this program to assist students to perform excellently in the forthcoming Senior School Certificate examination being conducted by NECO and WAEC as soon as schools reopen. Teachers making presentations will always provide their names and phone numbers during each presentation, and they can be contacted for questions, further explanations, and/or clarifications. The following numbers and contacts can also be reached for expression of any concern or observation: 090-865-00545 or 080-383-62072. Our website is www.education.kdsg.gov.ng. Our email education@kdsg.gov.ng or education.kdsg@gmail.com. Our YouTube channel, Ministry of Education, Kaduna State. Our Twitter handle @Kaduna_MOE. Or our Facebook page, Ministry of Education, Kaduna State. Stay safe, stay at home, and learn well. Thank you, happy listening, and happy viewing.
Hi, my student at home. You are welcome to Kaduna State Ministry of Education e-learning. My name is Williams Ishaku. I'm here to teach you chemistry. We will be looking at a concept in chemistry known as chemical combination. In this concept, we'll be looking at it under the following content. We'll start with the introduction, definition of terms, types of chemical combination, in which we have electrovalent bonding, covalent bonding, metallic bonding, van der Waals forces of attraction, and the hydrogen bonding. Under this type of bonding, we'll look at the formation, their general characteristics, and so on and so forth. So my student, before we start, you will recall in your knowledge of electronic configuration that electronic configuration is the arrangement of electrons in their respective shells. And if you look at that, take for example, we have atoms that have completely filled shell. In other words, they have attained what we call octet or duplex position. For instance, you look at element like helium with atomic number 4, and the electronic configuration is helium with atomic number 2, with the electronic configuration 1s2. In other words, it has only 2 valence electrons. We have neon with 8 valence electrons. We have argon with also 8 valence electrons, 2, 8, 8, 8. If you look at all these things, I know one of the questions that most of you want to ask me, why this chemical combination? I hope to provide an answer for you at the course of my discussion. If you look at the periodic table, looking at the periodic table, if you look at the periodic table, if you are not a science student, you may be tempted to think that it's just a mere table. But having acquired a certain knowledge of chemistry, you agree with me that the periodic table is the table that is representing everything on earth. Every element, because everything on earth is made of what we call elements. This is our periodic table. As you can see, it is an arrangement of elements based on atomic number. They are well arranged. We have the group 1, group 2, the transition metals. We have at the end of everything, the last column there you see is the what? The inert gases. These inert gases, they have fully filled valence electron. They have attended what we call octet position or duplet position. As in the case of other, you can see we have helium, neon, argon, krypton, xenon. All these ones are inert gases. They are called noble. They don't react. They are chemically inactive because they don't give, neither do they receive. They are chemically inert. In the periodic table, all the elements wish to be like them. And that is why they struggle to form bond with other elements so that they can form compound. Next, after the periodic table, it will be important for us to look at major key definitions whenever we are talking about valence electron. What is valence electron? Valence electron or valence shell is the outermost shell of an atom. The valence shell are called the valence electron. In other words, it is important to know that only valence electron take part in chemical bonding. Next, again, it is also very important for you to understand the concept of octet structure. Like I did mention earlier, it is the wish of this element to attain this octet position or duplet position. Octet in the case of argon, neon, and the rest of the inert gas element. Duplet in the case of helium as an element. They struggle to attain this so that they want to have either 2 so that they can be like helium, which we call in chemistry duplets, or 8 so that they can be like other noble gases like neon, krypton, and so on and so on. Again, that octet rule is this. It states that an atom continues to lose or gain. How do they attain this octet position or duplet position? Is by gaining or losing an electron. When they gain or lose electron, they combine with other elements. Why are they combining? They want to be stable. They want to obtain what we call stability. That is why they combine with other elements. Having known the definition of this thing, we also need to understand another definition, which we describe as periodic table. You will recall in our previous knowledge or lesson about the periodic table, my colleague discussed extensively about the electronic configuration of element. This element have what we call atomic number, and it is this atomic number that we use in writing the electronic configuration. Each and every element, when you are writing the electronic configuration, there are laid down rules and procedures. The first shell takes 2, the remaining one takes maximum of what? 8 electron. Then the last electron is what we describe as the valence electron. By writing the electronic configuration, we stand to know so many things about the knowledge of chemistry. One of them is through the electronic configuration that we can know whether this is a metal or a non-metal. We can know whether the type of chemical combination that may likely occur between one element or the other. Again, we use the knowledge of electronic configuration to state categorically the group or period in which an element belongs to in the periodic table. The periodic table is an organized table that helps us to know that this is the group in which this element belongs to based on their physico-chemical properties. However, my student, having known all this, you now know that we have a periodic table, one of the most important tables in life that helps us to do so many things. You can see we have under the periodic table, they are well arranged. To start with, now we are going to see the various type of chemical combination that we have. Broadly speaking, this chemical combination can be categorized into 2. The first one is interatomic bond. The second one is intermolecular bond. Let us see the interatomic bond. It is the type of bond that exists between atoms of the same or different element. They are either electrovalent bonding, covalent bonding, and metallic bonding. While the intermolecular bond, whenever we're talking about intermolecular bond, we talk about the hydrogen bond, the van der Waals forces of attraction. Having discussed that, we are going to pick them one after the other, and then we see their mode of formation and so on and so forth. To start with, let us start with electrovalent bonding. I know you may want to ask me, what is electrovalent bonding? How is this type of bonding formed? What are the characteristics of compounds that are electrovalent in nature? Another name for electrovalent bonding is ionic bond. Another name for electrovalent bonding is ionic bond. What is ionic or electrovalent bonding? It is the type of bonding that is said to exist between a metal and a non-metal. In this type of bonding, it involves the transfer of electron. It involves the transfer of electron usually from the metal to the non-metal. In this, the metal lose electron and become cations, that is positively charged, while the non-metal gain electrons to become anions, that is negatively charged. They combine together because they want to obtain what we call octet position or duplet position. Let us quickly see how this is purely formed. The formation of this electrovalent bonding, because it has to do with positive and negative ions, we talk about what we refer to as electrostatic force, according to the law of electrostatic induction in physics. Now, each time we're talking about electrovalent bonding, we look at it in two phases. The first one, we look at it in terms of before bonding and after bonding. Before the bonding, the elements that are supposed to be involved in the combination are in the form of an atom. Then after the bonding, they form what we call ions. How? If you look at the example above on the board, you will notice that we have sodium and chlorine. Just like we know, example of compounds that are ionic in nature, we have sodium chloride, we have calcium chloride, magnesium oxide, and so on and so forth. We want to use sodium chloride as an example for you to understand. When we are talking about sodium chloride formation, it is an example of an electrovalent bonding. How? Sodium has an electronic configuration of 281 before combination, and chlorine has an electronic configuration of 287. What will happen? Sodium, having only one valence electron, will donate that valence electron to chlorine so that it will be left with 28, while chlorine will now have 288. By this, they have obtained what we call stability in chemistry. They are now stable, and that is exactly what most of these elements want to attain. Having attained all this, the compound, because sodium now has, you recall that in our knowledge of electronic configuration, we made mention that each time we're talking about the number of protons and electrons, they are the same. But in this case, because sodium lost one electron to chlorine, it will no longer be sodium atom, but it will now be sodium ion. Now, chlorine, being that chlorine has gained another electron, it will no longer be chlorine atom, but chlorine ion. By this, ionic compounds are formed through an electrostatic force that binds them together. You see, they will now transfer electron. There is transfer of electron, usually from metal to non-metal. Now, this is briefly, there are so many examples. You may want to ask me, what about a case of a compound like we have something like maybe calcium chloride, where we have CaCl2. Calcium will have a valence electron of 2, and when it is combining with chlorine, chlorine will have a valence electron of what? 7. Where is calcium going to do after giving one electron with the remaining electron? Another chlorine atom will come up, and then we'll now have that as Cl2 during the combination. My student, having seen all this, it is also very, very important for us to see what are the characteristics of this ionic compound, which of course I'm going to take you. Now, the first one, you will recall that we said they form what we call electrostatic force. Because of that, they do not form molecules, but they form what we call ions. They form aggregate of ions. That is, they are held together by a very strong electrostatic force. The second characteristic is one, they form what we call crystalline solid. Almost all the compounds that are formed by this electrovalent bonding are crystalline in nature, which means they are solid in nature at room temperature with a definite structure. Again, they have high melting and boiling point because of the delocalized electron moving around. Their melting point and the interaction between the positive and the negative charge, to break it becomes very, very hard, and so they have high melting and boiling point. Number 4, they are soluble in water but insoluble in organic solvent. They are soluble in water but insoluble in organic solvent. They dissolve easily. You know, a common example is sodium chloride. In our respective home, we use sodium chloride from time to time, and you agree with me that if you add sodium chloride in water, what will happen is that it's going to dissolve. Now, they conduct electricity in fused or molten state as well as in solution. In other words, they are known as electrolyte. We know in our previous knowledge on electrolysis, we made mention that substances that are electrolyte in nature conduct electricity either in molten states or in aqueous state. Now, next is another type of chemical combination that we describe as covalent bonding. What is covalent bonding? It is a type of chemical combination that is said to exist usually between two nonmetals. In this type of combination, only nonmetals are involved in taking part in it. We don't have anything like a metal in it. It involves what? Sharing of electrons between either two similar elements or two different elements. E.g., bond like chlorine molecule, Cl2, bond like hydrogen chloride gas, and so on and so forth, bond like carbon 4 oxide gas. They are example of covalent bonding. How they share electron. In this covalent type of bonding that we're talking about, it can be categorized into two. We have the ordinary covalent bond, and we also have the second one known as the dative. If you don't want to call it dative, you can call it the coordinate covalent bond. We'll pick them one after the other and see how these bonds are formed. Using this diagram, you agree with me that the first element there is the formation of hydrogen molecule, H2. This type of bonding, we describe it in chemistry as homonuclear. Homonuclear in the sense that the elements that are involved are similar. You notice that hydrogen is having only one electron in its valence shell, and that it is going to combine with another hydrogen with another one valence electron so that they can obtain the helium pseudostructure electronic configuration, thereby giving us that structure of hydrogen molecule. That is by sharing of electron. You see the two of them coming in to share their electron. The only difference between these two types of covalent bonding between the ordinary and the coordinate covalency is that in the case of ordinary combination, covalent bonding, the electrons that is to be shared is being contributed by each and every one of the elements that are involved in the sharing. Whereas in the case of the coordinate covalency, the electron that is to be shared is being contributed by only one of them, the other one, both of them contribute. This one, only one will contribute. By this, that electron that is being contributed by that one element, we describe that electron in chemistry as a lone pair of electron. Now, how is this coordinate covalency compound formed? It is formed. You look at this example. A typical example of a coordinate covalency compound is the ammonium ion. How is ammonium ion formed? If you look at this, the electronic configuration, the valence electron of nitrogen is 5. 3 of those electrons, hydrogen will come and form bond, contributing one electron with it to form its own bond. Then two of the electrons will be left unbounded. Hydrogen will lose all its electron and then come back, will lose its electron and then come and form bond with nitrogen, giving us what we call nitrogen ion, ammonium ion, as you can see on this table. Then by this, you agree with me that the electron in which hydrogen is using is being contributed by only one of the atom, and that is nitrogen. Hydrogen is only coming in there to enjoy. By this, we move on to another form of chemical combination. What are the characteristics of this covalent compound? We said, unlike the other one that we say it exists in a form of ion, this one exists in a form of a discrete molecule formed through the sharing of electrons between the atom. Number 2, they are usually amorphous, non-crystalline in nature. Number 3, they have low melting and boiling point. Number 4, they are insoluble in polar solvent, but soluble in non-polar solvent. Organic solvent. They dissolve in organic solvent. They are non-electrolyte infused or molten state because they do not form ions. If you look at the characteristics of covalent, it is more or less the opposite of electrovalent. However, we will also want to look at another chemical combination known as the metallic bonding. You will recall that I said we have the electrovalent bonding. We also have another type of bond that is called the metallic bond. This is the type of bond, this is the type of bond that time will not permit me to finish up the remaining part of bonding, the metallic bonding, the hydrogen bonding. My student, I believe you have learned. We hope to continue in our subsequent lesson. But before then, I would like to call my able colleague, Mr. Philip Mamman, to come forward and then give you a review of our lesson. Thank you, stay safe, and remain blessed.
Hello, I'm happy to be here once again. I'd like to look at briefly what my colleague, Mr. Williams Ishaku, has presented this morning, and I will start by the definition of terms. He said that there are 2 types of bond based on either interatomic or intermolecular forces. And he said in interatomic, there is the one he referred to as electrovalent or ionic bond. An electrovalent bond involves metals and non-metals. It basically involves the transfer of electrons and is purely electrostatic, where the metals are electron rich and the non-metals are electron deficient. He also mentioned covalent bond, which has to do with share of electrons. But the difference between ordinary covalent bond and dative or coordinate covalent bond depends on where or the mode of share of electrons. While in ordinary covalent bond, there is mutual share of electrons, which corresponds to the number of bonds formed. While in dative covalent bond, the electron shared is donated by only one member or species in the combination. I mentioned metallic bond, which has to do with the orderly arrangement of protons and electrons in a sea of electron cloud, and that is responsible for certain important properties in metals like malleability, ductility, ability to conduct heat and electricity, and so on and so forth. My colleague Mr. Williams also talked about intermolecular forces, where he majored into hydrogen bond. And he said hydrogen bond is a bond that is formed when hydrogen is bonded to a more electronegative element, like oxygen, fluorine, just to mention but a few. But that hydrogen bond is responsible for certain properties in some molecules, like water. Hydrogen bond is the reason why water exists as a liquid at room temperature, and also why water has a irregular shape. That shape is sometimes called the V shape. It's always common in examination. You are asked to tell the shape of the molecule of water. Remember also that hydrogen bond is the reason why some organic compounds are soluble in water. These compounds include alkanols, alkanoic acid, because the existence of the bond between oxygen and hydrogen in the molecules. My distinguished students, as I round up my summary, I would like to quickly talk about van der Waals forces, which is a weak intermolecular forces that exist between molecules. These molecules are mostly gases, and they must be close together for this van der Waals force to exist. My friend also mentioned to you that the reason why atoms come together to form a molecule, or the reason why they combine, is because they want to achieve stability. In chemistry, stability is recognized in two ways, either by duplet configuration, as in the case of helium in an atom, or hydrogen when combined, an octet configuration having 8 electrons in the outermost shell. Thank you very much. A wonderful class. I hope that you paid attention and you got the things that you desire to pass your exams. I'd like to say you should stay safe and keep studying, because your exams is around the corner. Let me welcome my friend Malan Ibrahim Umar to come and give you an assignment to practice while you wait for your exams. Have a blessed day.
Good day, my wonderful students. That's a wonderful presentation by Mr. Williams and Mr. Philip. I would like to give you assignment that you practice at home in order to measure how much you have learned. These questions are probably WAEC questions because they are all gotten from past WAEC question papers. The questions are: question 1, state the types of bond that exist in the following. That means some can have only one bond and then the others can have more than one. So the first one is hydrochloric gas. The first one is hydrochloric gas. Then the second one is aqueous hydrochloric acid. Aqueous hydrochloric acid, that is in aqueous form. Question 3, or the third one is ammonium chloride, that is NH4Cl. In this ammonium chloride, it is important to note that we have more than one type of bond, because the first one involves the formation of ammonia, then the second one is the formation of ammonium ion, and then consequently the reaction between ammonium ion and chloride ion to form another type of bond. So I'm expecting 3 types of bond in ammonium chloride. 4th, zinc, the metal of zinc. 5th one, water molecule, and then the 6th one is hydronium ion. H3O with a positive sign, that is an ion, H3O. Question 2, distinguish between electrovalent and covalent compound. We are expected to differentiate electrovalent compound from covalent compound. And remember, I said it severally, that whenever you are asked to differentiate in chemistry, you are expected to draw a table. Give your differences in tabular form using corresponding points. When you say these are solid at room temperature, then I'm expecting you tell me that this should be liquid or maybe gas at room temperature. The points should be corresponding on a table. Question 3. With the aid of diagram, explain the formation of hydronium ion. Let me just give you a hint. Hydronium ion requires 2 types of bonding. The first type of bonding is formation of water molecule using covalent bonding, and then the second type of bonding is the formation of hydronium ion using coordinate or dative bonding. So you are expected to use the electron dots diagram to explain the formation of hydronium ion. Question 4. An element M with atomic number 12 combines with another element N with atomic number 17. State 1. The type of bond that exists between M and N. B. Write the formula of the compound formed between M and N. And finally, C. Give 3 properties of the compound that is formed. If it is a covalent compound, then you are expected to give me properties of covalent compound. If it is ionic compound, then you are expected to give me 3 properties of ionic compound. I'll take the questions again, quickly. Question 1, state the types of bond present in the following. 1, hydrochloric gas. 2, hydrochloric acid in aqueous medium. 3, ammonium chloride, that is NH4Cl. 4, zinc solid. 5, water molecule. And 6, hydronium ion. Question 2, distinguish between electrovalent and covalent compounds. 3, with the aid of diagram, explain the formation of hydronium ion, that is H3O with a positive sign. Question 4, an element M with atomic number 12 combines with another element N with atomic number 17. Now state A, the type of bond that exists between M and N. B, the formula of the compound formed between M and N. And finally, give 3 properties of the compound that is formed. My students, I will give you reference materials. If you want to study further, you can contact Understanding Chemistry by Godwin O. Ojikoku, or you can consult New School Chemistry by O.Y. Ababio and some other important chemistry textbooks. In case you solve the questions and you want to get to us, maybe you want to confirm whether it is right or wrong, or you have other questions that you want clarifications on them, or you need additional explanation, you can contact us using our contacts here. Mr. Williams Ishaku via his number 081-606-70920. Mr. Williams Ishaku, his number is 081-606-70920. Mr. Philip Mamman, 080-2659-8861. Mr. Philip Mamman, his number is 080-2659-8861. And finally, Ibrahim Umar with phone number 070-36-20-28-42. I'll take it again. Ibrahim Umar, phone number 070-36-20-28-42. Have a wonderful day, my students. Stay home, stay safe, and then abide by the rules and regulations given to you by NCDC to stay healthy. Thank you very much.